Hey, welcome. In this video, we're going to be solving absolute value inequalities graphically. So we're going to look at, we're going to start with this example where we want to let this function f be equal to the absolute value of 3 minus 2x. We want to graph this. Well, how would we graph this if, well, one way is to graph it using a graphing calculator, and we will do that on the next example. But if we want to just think about, well, how would this look? I can make a table of values. I can plug in an assortment of x's and see what the output of that function f is. So let's just start with, kind of those standard -2, -1, 0, 1, and 2. If I plug these into the function, 3, absolute value of 3 minus 2 times -2. So -2 times -2 is positive 4. 3 plus 4 is 7. Absolute value of 7 is 7. For -1, -2 times -1 is positive 2. 3 plus 2 is 5. Absolute value of 5 is just 5. 0, plug in 0. That just becomes 0. Absolute value of 3 is 3. When I plug in 1, I get 3 minus 2 is just 1. So the absolute value of 1 is 1. And we have 2. When I substitute in 2, I get 3 minus 4 is -1. And the absolute value of that is positive 1. So let's take a moment and plot these points. 2, -2, 7, -1, 5, 0, 3, 1, 1, and 2, 1. Well, we know that this is supposed to look like a V. Absolute value functions that are linear on the inside, meaning like the highest power of the x is 1, then it's going to look like a V. So I sort of see maybe there's a V here. Let's see what happens at positive 3. 3 minus 6 is -3. Absolute value of -3 is positive 3. So now we get another point. If we use a ruler, we can connect these. And I see here that here's our V. Now that we have that graphed, we can ask ourselves the 3 questions here. We're asked to find all the x's for which the function is greater than 5. So this blue or this purple graph is our function, and we want to know, when is that greater than or equal to 5? Well, that 5 represents the output, and output is our y values. So if I look, I'm looking at right here, when is this function greater? So when is the purple greater than this red line? Well, up in this direction on both sides. So, but we have to find the x's. Our x's are located, if we want to see what the corresponding x values would be, we drop down to the x-axis. And we want to include -1 because it's greater than or equal to. So we can include all of this in this direction because all of these values, any x value that I put into this function will have an output that is greater than 5. So for example, we don't see what the output is for -6 on this graph. It's off the graph. But let's just try -6. Let's try. What would happen? -2 times -6 is positive 12. 3 plus 12 is 15. Absolute value 15 is 15. It's definitely greater than 5. So all of these values, this is just one example, would have an output of greater than 5. Likewise, if I come over to this direction, I don't draw my line very straight, but it should be right there at positive 4. So if I come down, again, we want all of the values that are greater above that red line. I can come down here and I see positive 4. And it goes to the right. So in interval notation, I just look at my solutions along that x-axis because we're trying to find all the x values. We have negative infinity to -1, including, and then we have this gap. These values between -1 and positive 4 have outputs that are less than 5. They're underneath that horizontal line. And then we start back up at positive 4 and go all the way to positive infinity. Okay, for the next problem, we want to find all of the x's for which the function has an output less than 5. So let me get that. Remember, 5 is the output. We want to know when the function has an output, the y value, less than 5. Okay, well, the function is less than 5 when it is below that red line. So again, we want to know what the x's are. When we solve things, we are solving for x. So we come down to the x-axis and we're at -1. Do we include -1? Well, no, it's not. We can't be equal to 5. So we have to not include -1. And I'm going to the right this time because this entire section that I've highlighted in green here, that's all less than -1. Well, where does it stop? It stops at 4. So all of the x's where the output of the function is less than 5 is between -1 and positive 4. Notice that's the gap from the previous problem. The previous problem was greater than or equal to 5. This one's strictly less than 5, and this fills in that gap. Okay, for the next problem, it's asking, when is the function less than -5? So when is the output of the function less than -5? Well, -5 is here. Less than is below this line. Will the absolute value ever be less than -5? Nope. Cannot be less. It can't be negative. So what do we say? Does it have any solution? Are there any x's? No, no solution. There are no values of that function that are less than -5. Okay, for this next problem, instead of graphing by hand and making a table, we're going to use Desmos, an online graphing utility, and we're going to graph and solve this. So the previous problem, we looked at the a function, and in Desmos we're going to do the same thing. We're going to let the left side be the function f of x, and we're going to let the right side be the function g of x. So when we log into or use Desmos, we're going to type in f of x is the absolute value of 2x plus 4, and we're going to type in g of x is equal to 8. Now notice that I'm not using any inequalities in my function definitions. I'm going to strictly graph the function absolute value of 2x plus 4, and I'm going to graph the horizontal line going through the y-axis at 8. So here's Desmos. I'm going to type in f of x equals absolute value 2x plus 4. And I'm going to type in g of x is equal to 8. And they have my colors all flipped around. And I'm also not seeing, well, where did this g of x equals 8 go? Okay, so if I want to change the colors, here I'll do that again for you. I go to settings in this gear, and then I can change the color. I'm going to change that one to red, and I'm going to change this one to blue because that's what it was on my notes. I do like to color code things. It makes it easier to understand sometimes. And if I drag the graph down, I see my red line through 8. Now we're going to, let's see, plot a few points on our graph by hand. We see that it goes through the x-axis at -2, the y-axis at +4, and then we also have this point -4, 4. And that'll be enough to help me do this by hand. So in blue, I'm going to graph, it has an intercept at -2. Make my marker a little bit bigger. There. And we went through the y-axis at +4. And we also had -4, 4. And that will help me draw here. Whoop. Yeah, it's a bit big. Make that a little bit smaller. And going the other direction, and we see that nice V, our absolute value function. And then in red, we saw that we have this horizontal line going through the y-axis at 8. Okay. So solving this, we need to go back up here. We want the blue function f of x to be greater than the red at 8. So where is it greater? Up above. This direction. This is where the function is greater than that red line. So we come down, again, when we want to solve, we're finding the x values. So I need to come down to the x-axis, and I see that it starts at 2, and it goes to the right, including 2, because it's greater than or equal to. And over on this side, we come down, and we see that we're at -6 and to the left. So in interval notation, I go left to right across my x-axis. That'd be -∞ to -6 inclusive, together with 2 to +∞. In set notation, that would be we want all of the x's such that x is less than or equal to 6, or x is greater than or equal to 2. Now it's important to put the word or there because we can't have and. We can't have a value that's less than -6 and also greater than 2 at the same time. So it makes more sense to have the word or there. Now here's some for you to try. Again, using Desmos. So use Desmos. I want you to first let f of x be equal to the absolute value of x plus 1. And I want you to solve, again, solve means find the x values, where f of x is less than 3. The second problem that I want you to solve using Desmos will look familiar. 9 minus the absolute value of x minus 4 is less than or equal to 5. And again, you're going to use Desmos to solve that problem. Okay, work on those right now before you move on to another video, and bring those to class. And now that we've been studying absolute value, it's best to avoid negativity and just keep trying.